We're going to keep punching through these biogeochemical cycles. Absolutely will show up on the AP exam. First thing you need to know is that the major sink is the atmosphere. That's kind of unusual, right? We usually think of rocks or the ocean as being a sink for nutrients, but it's the air. Remember that the air is 78% nitrogen. That's a huge value as well. Second place is oxygen at 22%. Nitrogen gas is inert. It's a diatomic molecule, N2, nitrogen bonds with itself. The only way that it really gets out of our atmosphere are by tiny little bacteria in the soil. So when nitrogen interacts with the soil, bacteria are able to break it down. So this process of taking nitrogen gas, which is inorganic, and turning it into the organic form is called nitrogen fixation. And the first thing they do is turn the nitrogen gas into ammonia. Ammonification is the fancy name for that. And honestly, I'm not too worried about that step because it's an intermediate step. That's the first version after nitrogen is removed from the atmosphere. Then there are continuing bacteria which take the ammonia and turn it into something called a nitrite. You see, that's NO2. I'm also not too concerned about that step. Just know that it's multiple steps of bacteria that are converting the nitrogen to its usable organic form. So the final step are bacteria, again, more bacteria, which turn the nitrites into nitrates. If I ask you on a quiz, what is the usable form of organic nitrogen? The correct answer is nitrates. That's what plant roots need. Nitrates, NO3. The next step is uptake through plant roots. Uptake through plant roots. And that is also sometimes called assimilation. Assimilation is taking that organic nitrogen and bringing it into the plant. From there, it's just like the carbon cycle. It moves through a food chain. So that's how nitrogen gets into human bodies. That's the fixation process. Lots of little bacteria turning inert nitrogen into nitrates. All right, how does it get back into the air? Well, the answer is simple. It's bacteria. Bacteria control this cycle. They denitrify. Ooh, that's a fancy word, denitrification. That's the opposite side of the cycle, turning it back into atmospheric nitrogen. You see that on the middle of the chart, there are also decomposers. Remember, decomposers break down dead plant material. They take the nitrogen back out and put it back into the soil, where the whole process keeps going to fix it again. All right, now humans. That's the key to this whole unit, is how have humans impacted these cycles? So that was the natural cycle, but humans have sped up the nitrogen cycle in a ridiculous way. We can take, since there's abundant nitrogen in the air, we can take out as much as we want and turn it into fertilizer. Remember, the major ingredients are NPK. So that's called industrial fixation. Humans have done it through industrial processes. We can do it a lot faster than the bacteria can, just by splitting apart nitrogen gas. The problem with that, since we do that so much and we spread fertilizer all over the dang place, well, when it rains, we have runoff. That fertilizer gets carried into our watersheds, and we deal with the problem of eutrophication. Remember, eutrophication is an excess of a nutrient, and usually we connect it with nitrogen. We actually call it cultural eutrophication because this entire problem is caused by humans. We made the fertilizer, and then we allowed the fertilizer to collect in our water. That collection leads to algae growth, which blocks the waterways from photosynthesis occurring. Animals that live deeper in the water then asphyxiate. That's the end result of eutrophication. They are starved of oxygen. This creates a dead zone in the Gulf of Mexico after all the fertilizer that gets laid down in the spring. We call it a hypoxic zone, the absence of oxygen, hypoxic. There is one other human impact that's rather important. When we think of fossil fuels, we usually think of coal, carbon-based. But there are traces of nitrogen in fossil fuels as well, especially plant-based. And so when we burn fossil fuels, nitrogen is released into the atmosphere. It's not released as N2. It's released as something called nitrous oxide. Nitrous oxide actually comes in lots of molecules, so we indicate it as NOx because that number can change, the subscript. NOx comes from burning of fossil fuels mainly. Now the problem with that is that when it mixes with water in the atmosphere, NOx can form acid rain. So it's not the main culprit of acid rain, that's actually sulfuric acid, but nitric acid is another form of acid rain that is caused by humans. An additional problem from burning fossil fuels is that if you mix NOx with something called a VOC, which we'll learn about later, that is the major formula for smog. So human impact of the nitrogen cycle is the increased amount of smog, especially in urban areas. Fertilizer, smog, and acid rain, the three human impacts. There is also natural fixation when there's lightning. There's energy in the lightning strike, which is able to split the nitrogen molecule. In that process, you have also fixated nitrogen. So lightning fixes small amounts, nothing significant. I just wanted you to be aware that it also, in addition to bacteria, occurs. The main things here are that bacteria control the cycle and that nitrates are the usable form for plants. Those are the two biggest ideas, in my opinion.